Hello everyone and welcome back to ATPeak Open Source AR Talk Series. Today we are joined by Bastiaan Olij from Australia. Thanks a lot for being with us today. Bastiaan is the lead XR developer for the free and open source software Godot. He was initially working on this game engine in his spare time, but he's now working full-time on the project. And I think he'll tell us a bit more about that.
Okay, so Bastiaan will give us an intro to the Godot engine and how to put together AR simple AR game using the North Star headset or any other headset. I mean, in the XR AR game. Bastiaan, I turn the camera to you and let's start.
Okay, hello everybody, and thanks, guys. My name is Bastiaan Olij. I'm originally from the Netherlands, now living in Australia. And as I mentioned, I am the lead developer for the Godot engine on the XR side of things. I'm not the one who built the engine, just the one who built the VR and AR support into the engine. And that's what I want to talk to you about today. So I put a very simple agenda together for today. Just want to give an introduction about what Godot is, where it's coming from, what the history behind it is, how we got started with Godot and VR, and where we're at with Godot and AR at this point in time, and then give a small little demo about how you set up a project in Godot for XR, and basically, getting started points that anybody who wants to use this engine can start doing some AR stuff. So the Godot game engine itself was created by Jean Lozinski and Ariel Manzur a long time ago. These guys have been working on this for a while now. They are actually they made a bunch of games for the Argentinian market. That's where they're from. Did a bunch of engines over the years, and at some point sort of drifted more towards consulting work, if I understand correctly, and decided that they had this engine that they were working on, and this was, I think, the third or fourth iteration of that engine, and decided that it would be a good idea to open source it and see where that would take them. So that happened in 2014, where Godot was released. Godot 1.0 was released under the MIT license. And that's one of the things that attracted me actually to the engine, because of course with MIT, you're pretty free to do what you want to do with the engine. You can change it, you can use it as is, you can sell your creations with it. It doesn't really matter. It's a very free license. So that's something that definitely attracted me to the engine. As it says, we have over 1,500 contributors over the years, about 70 core contributors, people who come back every month and regularly do PRs on the system. We have an estimated 20,000 active daily users, an estimated 1 to 2 million installations. And this is information that we gathered from the different sites that you can download Godot from. You can download Godot in its normal form just from the Godot website, but you can actually also download it from itch.io, Steam. I believe it'll soon be available on the Epic Store as well. All free downloads, but obviously that allows some user metrics to feed back into us. Godot itself does not track anything. That's another thing that is very important to us. There is no telemetry. There's nothing that is being measured by the people who are using Godot. It's purely the feedback that we're getting from places like Steam, that we have a bit of an inkling of how big our user base is. It's an engine that's become incredibly popular with indie developers. And this is something that you can really see at, for instance, game jams or itch.io. The last GMTK game jam had over 13% of the entries being made by Godot. Really only Unity outshining us there. And you can see on itch.io with the counts there, I think we're about fourth right now with the number of projects that are on on HIO. So it's a heavily used engine. Godot made its entry really in the 2D market originally. That's really where the popularity originally started skyrocketing for the engine. That was one of the main focus. Oh, actually, talking ahead of myself, because that was the whole thing with Godot 3.4, our current stable release. So Godot 1 and 2 was really big in the 2D engine market. Godot 3 is where we really concentrated on bringing the 3D capabilities of the engine up to spec. So the engine was built with a brand new OpenGL ES3 renderer. Now it might be a little bit weird to hear the ES in there. That is because Godot is very popular also on the mobile market. That's a big target for us. So we wanted to have a renderer that would work both on mobile devices and on the desktop. Therefore, we restricted ourselves to the ES command set. And we implemented a GLES2 renderer as well, which is just a little bit more lightweight. So it runs on older mobile hardware, which is its main target. The other thing which is really interesting about Godot is it's small. It is really small. It is literally a 30 megabyte download. I think extracted, it's less than 100 megabytes. I think it's about 70 or 80 megabytes on Windows. So it's a really, really small engine. It's also a single executable. So it's just the one exe file or whatever executable format is on the other platforms. And that's it. That's the engine. That's what you run. And obviously that your game files get added to that, but that is the core of Godot. The editor runs on Linux, Windows, and macOS. What I didn't say on this slide is that there is an HTML version of the editor. But that is, well, it's pretty much finished by now, I think. I really need to check up on what the status is there. But it runs in a browser, and you can actually develop games in a browser. There's a couple of schools and universities that use it that way. There's also a Android editor version in the works. Not quite sure what the planning of that is, but that is, people are working on that as well so that you can actually develop on a tablet, which is kind of neat. Deploying wise, we do all the major platforms: Linux, Windows, macOS, iOS, Android, HTML as well. So basically all the platforms, if you make a game, you can publish to that. That is obviously a little bit less interesting for XR, where most is Windows and Linux centric. And then obviously for devices like the Quest and the Lynx R1, the Android platform is important there. Godot also has, by the way, WebXR support. So that is also one of the possibilities there, which is kind of neat. As far as language is concerned, obviously Godot itself is written in C++. And it being open source, anybody can contribute C++ code through the code base if they choose to do so. But the game development language is an internal language called GDScript. So that is the main option that Godot offers out of the box, which is a Python-like language, but it's very tightly integrated into the engine, making it very easy and very straightforward to write game logic. For the last 2-3 years, there is also that's actually probably about 4 or 5 by now. Time flies. We also offer a mono build of Godot, which allows you to write all the game logic in C#. And those are basically the 2 main options that Godot offers. Besides that, there is also a plugin system in Godot, and that's actually what we're using to enable XR development as well. But it also enables embedding other languages. So there are bindings towards Rust, there are bindings towards, I don't even know, I think even Python and D and some other languages. So yeah, in that way, the engine is quite extendable. But most people generally stick to the GDScript or C# if they're coming from a Unity background. The current version that we're working on, or the next big release, is going to be Godot 4.0. That's been in the works for well over a year now, probably coming up to 2 years by now. We're planning to release this version early next year if all goes to plan. And the really big notable thing that changed that is obvious is that we're moving away from OpenGL and we're going to a Vulkan-based renderer. So that obviously allows us to do a whole bunch of new visual effects and make things faster and better and all that sort of stuff. But there's also a lot of under the hood changes in Godot 4. I've mentioned here the change to the physics engine. Godot uses a built-in physics engine that covers almost everything that you want to do, and that's the one that's being really addressed in 4.0 and being built out. But in Godot 3, the other option that you have is using the bullet physics engine, and that has been kind of the de facto option in Godot 3, but we're moving back to Godot's built-in physics engine, and that one has been really updated with quite a lot of nice features, completing what it can do, but also has a whole multitasking back end now to make it very fast and make it capable of handling more than enough collisions and all that sort of stuff. For us, obviously, that is quite interesting because especially for AR, physics interaction is something that's very key. So yeah, that's what's coming. That's where we are heading with Godot. So that brings us to the topic at hand here, where it starts getting interesting for us. The XR support in Godot. Starting with VR support, that's where the focus has been since we started doing this. Now, the interesting bit here is, and there comes a bit of my backstory. I'm someone who has been developing graphics engines and graphics things as a hobby ever since I was a teenager. Active in the early 90s in the demo scene and doing all sorts of funky things there. But professionally, I went down a different path. I went into business software and still have a pretty successful career there. And then the VR headsets came out. Suddenly Oculus, Oculus probably was the first one that really hit the news with the DK1. That was, a dream come true for me. So I started hobbying around with that, started testing stuff out and learning how that all worked. And wanting to build an engine that supported VR. Now, I didn't want at that point in time to build an entire game engine. I've done that in the past, and that just takes a lot of time while I wanted to focus on the VR side. So I went looking for alternatives and found Godot. Godot was one of the things that one of my friends recommended to check out and said, hey, he has an open source game engine that might fit your needs. So early 2017, I started playing around with Godot. Started going and being active in the community there. Started talking to everybody about, this is what I want to do. And one of the things that I think is very key and very important for people who are going on a journey like that is I'm one of many at that point in time, right? I'm an unknown. Someone comes in, hey, I want to add VR support to this engine. And the people there sort of go like, yeah, you're number 10. And the other 9 said they were going to do it. And then they kind of disappeared off because they didn't know what they were doing or whatever. So that was my introduction, sort of. I met all these cool people and that I got on with. And then as what I wanted to do, I sort of went like, okay, well, go and do it. And we'll see what you come up with. And then we'll see what we're going to do. So I did. I wasn't deterred by that. I understand that attitude. On the contrary, it was a challenge. And mid 2000, probably about February, March 2017, we had a working prototype with a HTT Vive running VR in Godot. And that was the moment things started to change, because this was now, hey, here's someone who wants to do this. He obviously knows what he's doing. That's when, things became accelerated and we started working together and we came up with the solution that we still have in Godot today, with the main focus being on being as user-friendly as possible. we want to make the XR support in Godot as turnkey as we can. Now, obviously, Godot 3.0 was released early 2018. At that point, we were ready with our VR support through OpenVR. So I believe at that point in time at launch, we only had OpenVR support with Oculus Desktop, so support for the Rift CV1 at that point in time, I believe, being available quite soon after. And that were our two main drivers that we ran with. Then probably around 2020, we added Quest support to that. So we had the Oculus Mobile SDK and made that work with Godot. And ever since then, we've had support on the Quest. And then in the last year and a half, we have been working on OpenXR support and adding OpenXR support into the system. And one of the things that's really nice is a nice little link to North Star and the other developers who have been doing talks here. Is that Monado was a big part of that. It was actually one of the developers at Monado who needed a game engine to test Monado with. Godot works on Linux, and he wrote, this is Christopher Haag, he wrote the first OpenXR driver based on my work for Godot, and we've since taken that over and made it work on Windows and made it work on the Quest as well. So that is really how Godot VR support came to be. And we've been steadily growing ever since. So there's a number of cool projects going out of. I've just put a few screenshots at the bottom. VR Workout is a really interesting free workout application that I recommend everybody check out. It works on all major platforms, so that's pretty cool. One that we recently learned about was Friday Night Funkin' VR, which is a rhythm game. It's actually a game originally made in Haskell, I think. Not 100% sure, but it's a desktop game that someone ported to VR, and it's a really, really funky implementation of it. It's a lot of fun to play. The other one is VoxelWorks Quest, which is a Minecraft type game that one of our core developers made, with the big difference that here you're actually physically interacting with the world. So you're physically, hacking away with your pickaxe to do things. So quite a number of fun little projects that are coming out of the woodworks, and some serious projects coming out of the woodworks. Last thing that I want to say about this is the Twitter post that I posted here, which was a poll that Jean did a couple of months ago. Excuse me, let me just get a quick sip of water. Just to ask our community who is working on VR things and AR things and planning to. And out of the 1,500 people who replied, over 5% is actually doing VR stuff. That's seemingly still small, but 5% is still a sizable chunk of the community. But what I was most surprised at was that over 30% of our community is looking to do something with AR or VR in the near future. So there's a big opportunity there for us. So now it comes to what is interesting here, AR support in Godot. Now, unfortunately, I don't know if that's the right word to say, AR support has been very limited in Godot. It's really something that has always been something that we wanted to get into, that we wanted to start working with, but where it's sort of just kept on the radar and not really eventuated. And the biggest thing, not wanting to go all the way to the last option in this list, is actually the HoloLens, being one of the most prominent AR devices to come out of the woodworks very early on, but requiring DirectX to work. And Godot is, like I said at the earlier slides, is an OpenGL engine. And while there are some options to try and see if we can make that work together, time restrictions has not allowed us to go down that path. So what have we done in AR? Going back to the top of the list. First of all, Godot having a lot of potential here. It runs on Linux, and we can see that a lot of AR devices are coming out on Android, and we can see that a lot of the devices are coming out of Android now, like the Quests with pass-through support. like the Lynx R1. So there's definitely a lot of options there. The other thing, Linux is actually also the other important thing. I find it very interesting that in the open source area of AR, Linux is really where everybody is focusing their attention to. And you can see that with the North Star as well, where the options in the Linux are a bit more mature than the options in Windows. Godot, we've also looked at, the other form of AR, the handhelds, what runs on phones. And we had ARKit working very early on, somewhere around 2018, where we implemented that. But it's not really taken off. So that's been sort of sitting in the background with one or two people doing some really nice stuff with it. But nobody really pushing it further, which is really a shame, because I think ARKit is a really nice environment for people to get into AR. The other side of that, AR Core on Android, is something that is being worked on, but it's sort of, whenever we have time, we have a working technology stack there, but it's not in a form that we can release yet. So hopefully that is something that will come back to soon and are able to complete in the not too distant future. Although I secretly hold on to hope that Google will be smart and take OpenXR as their API for further AR development, because that really seems to be the smarter choice in my opinion. So as I mentioned, AR through the Quest pass-through is something that is now something that we are working on and actually already have a working version on. That's going to be in the next release. So when Godot 3.5 is released, it will be released alongside a new OpenXR plugin, and that combo will support Quest pass-through, and you can do some AR stuff on the Quest, which is really interesting. The other headset, which sitting on the chair behind me, I don't know if that shows up in the camera, is the North Star. Unfortunately, I got the North Star only a couple of weeks ago, so I haven't really been able to do enough with it that I could use it today for the presentation. That was what I was originally planning. And that specifically has to do with the fact that I'm on Windows. So when you're using Unity, there is a really good driver system for the North Star right now. But for us going through OpenXR, we're going to go through SteamVR. So we're using then the OpenVR driver for the North Star. And that's proven a bit unstable on my laptop. So it works. I've had some good fun with it, but not enough that I could really show off what that could do today. But it is something that I'm planning to do a lot more with in the coming months, and hopefully be able to show people more and more what we can do with that headset. So that's really it as far as AR support is concerned in Godot. So that brings us to the last and possibly biggest part of this presentation. Is I wanted to do a quick run through on how you can get started with Godot and setting up an environment that you can start building VR and AR applications in. I've put a few links here. I'll make sure that or ask Alex and Gail to put those into the description, and I'll probably make these slides available as well for anybody who wants to recap on this. But these are a few important links that we'll need, or that I'm going to be referencing in what we're doing. The most prominent is the GodotEngine.org website, to which we'll switch in a second. The other ones are we're going to use those indirectly. It's more be aware of those if you want to do more. Obviously, the GitHub page for Godot, where you can find the source code for the Godot itself. You'll see that there's a separate repository on GitHub, or a separate organization called Godot VR. We're too late to rename it to Godot XR, unfortunately, and renaming it now seems to be a bit troublesome. But on there, you find all the drivers. So you find the Godot OpenXR driver and stuff like that. However, you can download those from the engine interface as well. So it all works pretty seamlessly. And last but not least, I put my YouTube channel there, a little bit of self-promotion. I've got a whole bunch of tutorials online on how you can do things in Godot that are XR related. So check it out if that's something you are interested in. All right. So going to the Godot engine website, that is obviously where everything starts. And really the only thing that is important for our demonstration today is the download page. So you simply go to download and you can find the two versions that I was talking about before. The standard version, which uses GDScript, and then the mono version, which still supports GDScript, that's not solely taken out, but which adds the C# support into the engine. I am going to be using the standard version today for this demonstration. Now, I've already downloaded it, and I've already got it up and running. So when you start that up, you are presented with our project manager. And obviously, the first thing that we want to do here is create a new project. I might as well put that there. It doesn't really matter. We'll create a folder for that, and we're going to create our demo in that folder. Now, it gives us that choice between those two renderers that I was talking about, the ES 3.0 renderer, which has all the bells and whistles that you could possibly dream of, and the lower quality but faster ES 2.0 renderer that is targeted at more mobile games. If you want to target the Android platform, so if you want to do things on the Quest, I would definitely recommend going to the ES2 driver. But for what we're going to do today, we're going to stick with the ES3 driver. And we simply press create, and that launches us into the engine itself. I'm not going to give a whole tutorial about how the engine itself works. There are plenty of those tutorials online. I'm just going to focus on the basic steps for what we're doing today. We are right now presented with an empty project, and it asks us if we want to create what we call a root node. Godot has a tree structure that makes up our game, and every tree starts with the root. So we're going to create a 3D scene, and I'm just going to rename that to main. That's just my personal preference. And then I'm just going to save that, and that saves to a file called tscn. That is our scene file. So we'll just keep that as is. Oops, come on, go away. My little screen sharing thingy just dropped down right over the things that I need to click. So next step is that we're going to go to the asset library. So Godot has a built-in asset library that allows, basically any user of the Godot system is allowed to upload assets to this library to share with other Godot users. The current limitation there is that those do need to be free and basically open source as well. Though the asset library itself really is a collection of links to repositories. So most of these actually are stored on a GitLab server somewhere or a GitHub server somewhere, and you just download them from there. So we need two of them. It doesn't help if I learn how to type. So the first, obviously, is that we want our OpenXR plugin. So if we search for OpenXR, we find our OpenXR plugin. There we go. And we simply hit download, and that's going to go and download our plugin and then give us a option to install. Now, this plugin is already bigger than our engine, and that's mostly just because there are a couple of assets in here like hand models and stuff like that with relatively large textures that make up the bulk of that size. Code-wise, there's not a whole lot in there. And if you want to have a smaller deploy, you can remove the bits that you don't want. So it just gives us a confirmation here. What parts of the plugin do we want? We want it all, so we just press install. And there we go. Now this is going to take just a second because it's going to process our images. So we just have to wait for that for a minute. But it always breaks up the. Come on. Don't take too long for this. All right, I'm sorry if my sound breaks up for a minute. I forgot that this always breaks up my connection. Should be done in a minute. My apologies for this. Okay, that should be past the difficult part. So again, my apologies for that little breakup there. I had forgotten that converting the images is always something that Godot stalls a few things on my system with. I'm not quite sure why it does that, but it is a little bit of a problem. Now, the other thing that I want to quickly install is a little helper library called the XR Tools helper library. And this is just a library that has implementations for some very common features that you would want in an XR game. Mostly right now focused at VR games, but hopefully we'll be building more AR-centric things to that. Think of movement, logic for picking up items, that sort of stuff. So same principle, we just click on it, we say download. This one should be a lot faster. This one doesn't have many images and stuff like that. So there we go. That's already in there. And what we now see is that in our folder structure here, so this is our project folder, we can see that we have our OpenXR plugin and our tools plugin now installed in our game. So the first thing that we're going to do is we're going to click this little button here, which adds in a subscene. So like I mentioned, Godot is built up of a tree of nodes. That's where all the game objects live and all the additional objects live. But they don't have to be all in one big file. You can make little mini scenes with encapsulated logic and then bring them into another scene. And that's something that we're going to do. And from our add-ons OpenXR plugin, we're going to bring in the first-person controller scene. And what this does, it brings in all the basic elements that we need for a player character to work. So the other thing that I'm going to do here is I'm going to right-click on that, and I'm going to take on this editable children, and that shows us all the elements that are in here. And specifically what is important for us is our left-hand and right-hand controller, because we're going to want to add functionality to that. So obviously our left-hand and right-hand controller will track the position of our controllers in space. When you are working in an AR environment where you do hand tracking, obviously those positions will track where your hands are. However, there are multiple places that we can track, especially when you are using controllers. Again, that's more VR centric, but it is important that the system is unified. So whether you are building a VR game or whether you are building an AR game, Godot tries to take the same approach to both. However, when we want to do finger tracking and when we want to visualize our hands, that's something that we have added some extra support for. And again, we can just bring those in. So you can see that in those scenes, we also have a left-hand mesh and a right-hand mesh. There's also a nodes version. The difference is that the mesh is using a skinned mesh. The nodes is just using just objects. So that one is actually a little bit better suited to VR, to AR, but I am going to bring in these because they're prettier. And we just add them as elements to our FPS controller. So we have that one and we have that one. So you can see that that brings in some hands. There we go. And in essence, we have all the basic elements to make something like this work. So we could actually save this and I could quickly run this. And then it asks which scene it wants to actually start. Excuse me. And once this whole thing goes and it tracks my hands. It's not picking up my base station for some reason. Because I forgot one step. I forgot this because this is something that we changed in the latest version of the plugin. That should start automatically. But in this version of the plugin, I need to write one line of code to actually kick this off. And all I need to do here is I need to say FPS controller initialize. So obviously, and this is because before OpenXR was only working on desktop and we were still using the Oculus plugins on Quest, we had to make sure that you could use them side by side and they didn't start automatically. We change that now in the next version of that plugin that it will start automatically. But in this version, we need to just write one line of code to start it up. And hopefully now we have tracking. Now, obviously, there's nothing to see because we didn't put anything in our world except for our hands. And we can see that our hand is nicely being tracked. And obviously, this is not actual hand tracking like the Leap Motion does. But I've tried this out. Like I said, I did get the North Star to work a couple of times. And it actually tracks it pretty well. It does have some problems with the mesh version of this because the mesh, the skin mesh expects that hands to be a certain size. So if you have a smaller hand or you have a bigger hand, then obviously the bone data is not going to match up and you get a scrumpled up hand, which is hilarious and funny, but not really what you want. So if you're working with that sort of stuff, I highly recommend starting off with the nodes one or creating your own. Now, OpenXR does have some features that we're still looking into that will give us a hand model that is generated. I know that Microsoft implements this properly. I'm not sure if the other runtimes do yet, but that's one of the things that we're still looking into so that you can actually have proper hands that match over your hands. Now, obviously, in AR, you're seeing your physical hands, so there's also an argument of not rendering the hands at all. You just want to know where the fingertips are and working with those. All right. Now, one of the things that I want to change is I want to put a world environment into here. And now my camera is a bit in the way, so sorry, I'm going to make this a little bit bigger. Can I move this? I can move this. You guys probably didn't see the camera, but I do. I'm just going to create a new environment in here, and we'll see that everything suddenly changes. Our background is gone and all that sort of jazz. Now, when you're using the pass-through logic on the Quest, and I'm assuming that that's or a similar version of that is also going to be working once we're able to play around with the Lynx R1. It will actually automatically erase the background, but in this case, we actually want a black background instead of the default background that we have. And that also means that I want to get a little bit of ambient color in there so that we can actually see our things. And for now, I'm just going to put in a light source just so that we have something illuminating whatever we put into our scene. All right. There we go. Happy enough with that. All right. So let's see if we can add something that we can pick up. And that's really I think the last step that we want to do here. We don't want to spend a whole bunch of time on this. The first thing that I need to do is I need to create something to put some stuff on. So I'm going to start using our physics engine by creating a static body. I'm going to add in a mesh there. And I'm just going to create, where are you? QMesh. And I don't want it to be this big. No, I want to, yep, that's kind of good. I want to make that a lot smaller. There we go. And let's make that's way too small. Make that something like this. Bring that up. Bring that up. Now, one problem that I'm going to have here, and that'll take a little bit of trial and error right now because I don't want to spend hours and hours building, a whole thing here. But one of the things that is important is this FPS controller is what we call an origin node. So you can see that point is on the floor here. Now, when I move around space, obviously my camera and my hands are going to move through my virtual space in line with how I'm moving through my physical space. So that point, this point on the floor here, maps to the center of my tracking space, which for me is somewhere behind me in the middle of my room, which means that that desk isn't going to be in front of me. It's going to be wherever the center of my room is. Now, obviously we can center our player. But again, that's something that I don't really want to get into right now. So we might need to place that manually to make sure that it actually comes near my desk. We'll have a look at how well that works. But I don't want to put a collision space on this. Did I actually move that correctly? Let me just double check. Yep. No, I did not. Okay. I need to move the static body, not the object, because else my collision shape and my mesh do not line up. So that needs to become a box shape. And we're going to size it the same. That actually needs to be, no, I'm looking at the wrong one. That needs to be half that. We made that, what did we make that size here? Strangely enough, they need to be half what we have here. So that needs to be 0.0. This is all in meters. So this one is now going to be 1 meter wide because it extends. It's from the center. It is going to be 5 centimeters high. And I believe that was, yeah, half a meter wide. So that's how big our little table is going to be. Oh. Yep. Yep. So let's see where our table is to see whether it's somewhere where we want it to be. Come on, track. There we go. All right, I'm gonna go and look around. Yeah, and like I said, it's in the middle of my room, so it's way behind me. Let's see if we move it like this, whether it's going to be in a better position. So once it's in the right position, then, you know, obviously it's always tracking the same volume. But that was the wrong way. So it's actually the other way. That's interesting. So we're going to go and move this over here then. And I'm guessing I need to move it somewhat to the left then. I don't know. I might have moved it. I might need to move it to the right. I don't see. Yeah, it's the right distance, but it's indeed in the wrong direction. Okay. So we're going to move it over here, and I'm going to move it a bit back. And hopefully it's now going to be somewhere in front of me so that we actually have something to work with. Well, it's slightly too far still, and my hand is way too. I need to put the ambient a bit higher because I can hardly see my hand. Well, I probably should have kept the background on just for this demonstration, but obviously I wanted it to be black because in an AR environment, obviously the black isn't going to render anything. That's where you're going to see through your AR glasses. So I'm going to put that over there. And that just gives us a little working desk, which hopefully is near enough that I can work with that. I'm also going to go and put my ambient color up a little bit so that I can actually see my hands, which would be nice. All right. Now I want to have two more elements into my scene. One is I want to be able to find something that I can pick up. And I want, of course, my hands to actually be able to pick up things. So for our hands, this case, I'm going to work on our controllers here. I'm now going to look at my XR tools, and I should have a function here called pickup, and I'm just going to add that to my left hand, and I'm going to add that to my right hand, and that adds, that was the wrong one. And that adds all the logic to my hands that allow me to pick up things. Now, again, this is a VR-centric bit of logic. So that's something that we'll work on to be more akin to how you want to do pickups on AR. But for now, you know, that's our starting point. That's what we are working with. Now, the other thing that I want to do, and I'm going to make that a child of my table for now, but we're going to go and save that separately, is I want to now have an object that I can actually pick up. Now, again, we have a helper scene there, which is called Object Pickable. That's a little bit of a weird name. I should have named that differently, but it is what it is. And I'm now going to say, well, let's just keep that the way that it is. Oops. I'm now going to just move that down my tree a bit. Come on. I want to do that. Do it like this. The reason why I made it a child of my table, actually, let's go and rename that to table, is I just wanted to make sure that I was in that position so I didn't have to reposition it. I do need to move that slightly upwards. We're going to add a mesh to this because, again, we want to be able to see what we are picking up. And let's make that a capsule. No, not a capsule, a cylinder. I wanted. Where's my cylinder? Here we go. And unfortunately, that is way too big. There we go. Why did that go right? There we go. It's better. I should have had some little objects that we could pick up, like a cup or something like that. But we'll just do that. I also want to give that a different color so that it stands out from our table. So where's my color? Here's my color. There we go. And we're going to put a collision shape on that one. I still have that in my recent used. Not sure why that's suddenly collision shape too, because it's in a different place. Or, oh, hold on. I remember now. Hold on. And let's go and delete that. Can we save that as a separate scene? Okay. My apologies. I should have started that differently. So I'm going to restart that bit a little bit. This is what you get when you do live demos. You sometimes get mixed up. I actually wanted to inherit my my object to create a new object. So I'm just going to rename that cup. We're going to save that over here. Can I copy paste this? I don't know if I can. Yes, I can. So my cup is now over here. That's cool. Why is that not centered? I don't know. Okay, that means that I can now remove this. Make sure that that is saved. And now let's go and bring in my cup. That's better. And we can now make sure that's separate. Okay, that's okay. Unsave. That's right, because I actually need to edit the existing shape there, because that's how it ties into the logic that we have. Why do I always go to capsule shape? I don't want a capsule shape. I want a cylinder shape. There we go. And then the same thing applies here for the sizes. So I'm going to have to make those sizes the same. There we go. Is that right? It is right. There we go. We've got our thing set up. Okay. Let's see how much of that worked now and whether I can actually reach it. We got our hand, but my cup's gone. Where's my cup gone? What happened to my cup? Look at this. Okay, let's go and double check everything. So we got our table. Perfect. How's the collision shape on our table? That's matching, so that's good. What is our layers? Just on layer one, that's great too. What are our layers here? We're on layer one as well. So why did our cup disappear? We got our mesh, that's fine. We got our collision shape. Okay. What's going on? Why? Maybe difficult. That's fine, that's fine. Okay, am I going crazy or is it just falling through? There we go. Okay, this is strange. Why is my cup disappearing? Now, I'm just going to try something a little weird just to make sure that it's not that. I'm just going to make this real big. Just want to make sure that it's not just falling through. And I do need to put my table a little bit more closer as well. Good. Go on track. There you go. Okay, so my collision shape was way too small. And that's something that does happen. And I'm not going to spend time right now diagnosing that. But obviously it didn't like that and it just dropped through my table somehow. Now I did mention that my table was still not really in the right position. Let's move that over here. Let's see if my table is now nicely in front of me. Or at least close enough. That's too close. But we're about right where we need to be. So let's just do that like this. Let's do this one like this. And hopefully it now works. All right, here we go. Oh, come back here, you. So maybe it's still a little bit too close, but I can pick up my little cap. I can. Now at this point it snaps to my hand because that's one of the options that I have. So that's something that we can change. All right, and for some reason it rolls a little bit. That's because the margins are wrong. That's easy to fix. Then go back to our cup, and all that I want to do here, I want to make that a lot smaller. Stop it from being round. Let's put another cup there. So that we have two cups to play with. There we go. And I am going to move the table a little bit more this way because it went a little bit crazier. What else did I want to do? Oh yeah, I wanted to have a look at the settings here. So I want to undo reset transfer on pickup because that is what snapped it to my hand. I want it to be and stay the way that it is. All right. Oh, my other hand too. Let's do both hands. Oh. And I need to put my range a little bit smaller, I think, because it is very precise grabbing right now. Very easy to grab. I think I just touched my, it doesn't really want to stack too good. Come on. Okay, I'm at the edge of my tracking boundary, I think. Doesn't want to stay on top. So probably still need to play around with those margins a little bit, but yeah, it does work. I can manipulate. Why is my left hand? Maybe my battery is low. There we go. Also just, I just threw that in there. Okay, so that needs a little bit more tweaking before it starts working dependably, but it does work. So that's really as far as I wanted to go with the little coding demo. There's a long way to go from here to really start building it out and doing some cooler things. At some point in time, I do want to create a proper AR demo where, again, a lot of this stuff is really focused on the VR side of life. And you can see that when you're working this up close with some things, it is the default settings aren't really where we want them to be. But you know, it's where we are right now. It is where what we can do right now. So, does that go back to the start? No, it goes back to here. Good. So that was just a really quick run through of the steps that you need to take to start a new VR/AR project in Godot, bring in some default behavior, and get yourself a starting point. Like I said, if you do want to do this with the North Star, from what I've been told by others, on Linux, if you use Monado with the North Star, the OpenXR driver for Godot should work. On Windows, like I said, I have been playing around with the OpenVR driver for the North Star, and it works, but it doesn't work consistently. And I think that's on my side. I think that is the way that my laptop is set up, that it's getting confused because I've got a streaming capture device attached to this machine. I've got a second screen attached, and I think it's getting mixed up with where the North Star actually is. So that's something that I'm going to be continue working on and trying to get that work more stable so that I can start, implementing things which are much more AR centric. And well, that's the plan for the Godot side, at least. And hopefully, within not too long, a lot of these functions that we're implementing will be, working out of the box in an AR environment. So that was really where I wanted to sign off. So thank you all for listening in. And I believe that we're going to have a Q&A after this. So it's back to you, Alice and Gil.
Thanks a lot, Bastiaan. If you want to switch back to your camera, so we can see you on the screen. Perfect. Yes. Hi. Thank you for the presentation. That was really interesting to see how the engine works. Yeah, and I think that some classes would be a good idea for people to dig deep into the engine.
Yeah.
Well, obviously there's only so much that I can really quickly show in just an hour session. And the other option that I would have liked to be able to do was actually start with a fully worked out example, but I just didn't have enough time to look at the AR side of things. However, just to plug myself a little bit, obviously there is a lot of tutorial work on my YouTube that is all VR centric. So that's definitely that people who are interested in going along on this journey and trying out their own things and seeing how they can use the engine to their projects and bring that back into the community, which is obviously what open source is all about.
Yeah, sorry, we have a little
problem
with the audio, but
good.
All good now.
Yeah, the questions I have, like, it's what do you think would be like well, questions. The first is like in terms of like in the engine itself, what do you think would be for XR some tools to help like itself, or I mean in the future, what tools do you foresee to help? Like you were saying, like positioning, or XR is different. I mean, AR is different in VR, so you will have contacts and real. But I like even the idea of having a real environment. So bringing in some maybe point cloud of your environment just to play around, to do debugging without moving around continuously.
Yeah, exactly, and that is really interesting, because that is the element where there is still a lot of development to be done, or the development is there. When you look at HoloLens, for instance, and the way that HoloLens is able to scan the room around you and bring that in, and I know that Oculus is working on that as well for the Oculus Quest, where the Quest knows about your surroundings and knows what's around there, and then bringing that into your game engine. It is that part, that bringing that into the game engine, that is where there is still a lot of development left to do. When you look at, for instance, the OpenXR spec, the OpenXR spec is right now fully focused on, okay, how can I interact with the headset? How can I make sure that that I get my tracking data? How can I make sure that I'm displaying the right things onto the screens, and making that in a way that it doesn't really matter what headset you're using anymore. Your game logic will be the same, which lines up a lot with what we're trying to do as a game engine as well. There isn't a clear definition yet for an API to bring the data of your world in. So when you look at a VR headset, especially one that is working with like room scale tracking, all you really know is what the boundaries of that room are and what your center point is. So all that logic to then go to that next step and say, where is there a table? You saw how I was struggling with just putting a a virtual table into the position where my table is right now. That is something that the environment should do for you. It should detect there is a table in front of me, and then let the game engine know, hey, there is this surface in front of you, and bring it in. And right now, the only experience that I personally have had with that is actually an AR kit, which already had that logic built in pretty much from the start, where all this information was brought in. And I expect those things to, because again, they exist, right? HoloLens does it right now. I know that Oculus does it. It's just not part of the open spec yet. And I think that is where the next big breakthrough, or the next big step lies, I should say, is defining that API, defining that standard where all the different implementations feed that information in a uniform way into a game engine, so that the game engine knows about the environment, and therefore you can interact with the environment. And instead of trying to place a table somewhere that matches, you have it there, and now you can just put a cup on there, and you can interact with that world. So yeah.
Yeah, that's pretty interesting. Yeah, it's like I was expecting it's really that. Yeah, that's the and the other part. So okay, this is one question. The other question would be, what do you think? Well, definitely this is the future. What do you think would be like a short-term development that you are working on why we see like Godot from now in the next 6 months, 1 year?
When we're looking at Godot itself, the focus right now lies on basically expanding what we have right now. So, like I said, the last year we've been working on getting everything to work in OpenXR, moving away from the proprietary plugins that the various vendors have. So, our sights really now are on completing that, making sure that it has all the bells and whistles that are in there, and making sure that we support as many of the headsets that are out there. The other thing, obviously, that is in the next 6 months, is the fact that we are looking to release Godot 4 at the end of that period. So there is still work to be done to make sure that everything AR and VR works on the new environment. That means switching everything over to Vulkan, and that's what we're currently in the middle of, and at the end stages of a first release. A first beta that we can really start testing with that. And my personal hope there, and I'm not sure if that's going to be in the next 6 months or if that is going to be in the next 12 months, but I want to shift my focus more on the AR world. So I'm a big fan of VR. I love playing games, but I think when we are looking at the future, I see the split between AR and VR, where VR will probably remain in that game area for a long time and be, that's where the strengths of VR lie, while AR is going to be on this path of, okay, how can we actually use this technology to increase the productivity of us, whether it is in the workspace, whether it is in our private space. How can we use this technology to really augment our lives and make it do something useful for us, not just a toy, but actually, do something that actually improves our lives. And yeah, for me personally, I think that is a multi-year track, but that is something that I want to make sure that as that evolves, that Godot evolves right with that, and that we're able to use these AR devices just as easily as we can right now do stuff in VR in Godot.
Yeah, pretty cool. Yeah. It's it sounds like it's a lot of fun. I think you have a lot of fun a lot of development fun ahead, and we're excited to. Well, we look forward to the new release of Godot, and yeah, I mean, definitely will take quite some time on the XR path to become really useful. I think for everyday use also, or just for will like every technology will be bringed in, and yeah. So well, so thank you very much, Bastiaan, for being here and show Godot to us, and also to for the live demo was really fun. I mean, to see it live. so yeah, and thank you everyone else too for tuning in and seeing the presentation. We next Tuesday, November 30th, we are super excited to welcome Nova, who will talk to us about Stardust XR. Stardust XR is a project to make a new XR focused display server. Nova will show off Stardust programs that use it and implement UI elements and how to make it on your own. Don't miss it.
We would like to thank all of our partners for their support in this first open source AR Talk Series. And if you'd like more information on ATPeak and the lineup for the open source AR Talk Series, visit our website, atpeak.io, and hit the subscribe button not to miss any upcoming guests. And check the AR Talk Series playlist to set reminders for future guests and rewatch our series. Thank you very much.